All right, friends, we are today going to be on page 93, 93, page 93. And today we're learning about another word that starts with the letter I. Ions, yes. What's the other word that we know that starts with the letter I in this unit? Isotopes. And just to remind ourselves, what are isotopes? Different variations of, well, if you want to, you can. I'm just like, reminding you. Yeah? Different variations of what? An element. What is different about them? The number of neutrons is different. And because the number of neutrons is different, what else is different? The mass is different. So isotopes have different neutrons. Yeah? Isotopes have different neutrons. We're going to change something different today about our atoms. We're not going to change the neutrons today, and we're not going to change the protons because protons will change to a different element. Today we're going to change the electrons. What charge do electrons have? They are negative. So what happens to something if we put an extra electron on it? It becomes more negative. If we take away an electron, it becomes more positive. So that's the idea we have with ions today, and Tyler is going to take a look at this. And was there anyone else who was away yesterday and did not get the notes? These were the notes from yesterday. So let's hang out with Tyler and go through this together. Are we all plugged in? Why is it not going? Hello, let's go. There we are.
Okay, what's an ion? People talk about ions all the time.
Okay, we're going to put on some closed captioning. We're going to make it bigger. And here we are learning about ions.
Chemistry. So what are they? Well, an ion is an atom or a group of atoms that have an electrical charge. Okay, that's all it is. Now, how does this happen, though? Well, inside atoms, there are two things that have an electrical charge. There are protons that have a positive charge and electrons that have a negative charge. A lot of times in atoms, the number of protons is equal to the number of electrons. So the charges balance out and you don't have any total charge. But sometimes an atom can gain or lose electrons so that it gets more or fewer electrons and protons, and then the numbers don't balance out anymore, and it's left with more negative charge because it has more electrons, or it's left with more positive charge because it has more protons. Let me give you a couple examples of how this happens. Let's look at the atom sodium. Sometimes when I'm talking about atoms, I'll just draw them as the element name inside a circle to indicate that that's the atom I'm talking about. But for our purposes, we're going to want to zoom in a little bit more. Here I've drawn two things in this zoomed in version of the atom. I got protons here in the nucleus in red, and then flying around on the outside, I have these electrons, which I've drawn as black dots.
What has he left out of this model? Neutrons. And it's because for the purposes of ions, they don't matter. Okay? Like you could have an isotope with versions with more or less, but it doesn't matter in terms of the charge because neutrons are what charge? Neutral.
If you know a lot about atoms, you might know that I've left out the neutrons, which also live in the nucleus. But it's no big deal because neutrons don't have a charge at all. They're neutral, so they're not important for what we're talking about here. Anyway, right now, sodium has, if we counted them, 11 protons here in the nucleus, and it has 11 electrons flying around outside. So the number of protons equals the number of electrons, which means that my total net charge is 0. They cancel each other out. And so something that has no net charge, like this sodium atom, we call it neutral. Okay? But here's what can happen in sodium. You see this electron right here? It can lose this electron. It can lose it, and it flies off and usually goes into another atom. So let's look at what happens when this electron here gets lost. And now we're going to end up with a sodium atom that has...
How many protons does it have? 11. Now it's got one less electron. How many electrons does it have? 10.
11 protons, just like it did before. But now because it's lost this electron, it used to be here, that was here, now it's not here anymore. Now it only has 10 electrons.
So has this atom changed into a positive ion or a negative ion? Positive, because it's got more positives and it lost one negative, so it became positive. Yes. Sorry. All right.
So now the positive and negative charges don't balance out anymore, and I'm left with more positive charge than negative charge. So this thing now is going to have a charge of +1, one more positive charge and negative charge. And so I can write this, if I want to talk about the atom, I can write it as Na plus to show that it has a positive charge, whereas this, when I'm talking about a neutral atom, I'll probably just write Na.
Now you'll notice that charge, that positive charge, what side of the symbol does it go on? It goes at the top right. That's because we've already taken up the space at the top left and at the bottom left, because those would be, what would go at the top left? Mass. What would go at the bottom left? The bottom left would go the protons or the atomic mass. Okay, I feel like this side of the classroom got that. How about this side of the classroom? Did we get it? Yes? Excellent. What goes at the top left? Mass. What goes at the bottom left? Atomic number. Okay. At least Celine got it. I don't know about the rest of you. All right.
So Na plus here is an example of an ion. It's an atom that has a charge, and it's a specific type of atom. We have a name for this. We call it a cation, which is what we call an atom. An ion, what we call any ion that has a positive charge.
Okay, so the name of a positively charged atom is called a cation. And if you have trouble, and it looks like it could be pronounced cation, but it is not pronounced cation, it is pronounced cation. And if you have trouble remembering that, you can think that a cat, what does a cat have? Paws. What charge are cations? Positive. Oh, yeah? The other thing you can think of is that cation has the letter T in the middle of it, and if you write it as a lowercase t, what does a lowercase t look like? Lowercase t looks like a plus, so it's positive. That's two ways to remember that cations are positive.
Okay, let me show you another example. Okay, so here's an atom of oxygen. The atom that I've drawn here has 8 protons here in the nucleus, and it has 8 electrons outside.
And 8 is, what do we call that number for oxygen? 8 is called the what number? That is the atomic number. Yeah.
So we have the same number of protons and electrons, which means that the total charges balance out. The plus and the minus balance out. So I have a net charge of 0, and I can say that my oxygen atom is neutral. It has no net charge.
So anytime we say we have an atom, that means we are assuming it is neutral. Okay, so it will have the same number of protons and electrons. The moment we change the number of electrons, it's no longer called an atom, it is called an ion. Okay, so when we change the charge, it becomes an ion.
But oxygen can gain or lose electrons, and actually it really likes to gain 2 electrons. And here's a picture of the oxygen atom after it's gained 2 electrons. And now it still has 8 protons in the nucleus. And if I count up these electrons, it now has 10 electrons instead of 8, which it had before.
What will its overall charge be? Will it be positive or will it be negative? It's going to be negative. How much negative? Anthony? -2, yes. Okay, because it's got 2 extra electrons, 2 extra negatives.
So now the protons and electrons don't balance out anymore, and I have more negative charge than I have positive charge. I've got 2 more electrons and protons, so that means that my total net charge is going to be 2 minus.
And one thing you'll notice is that if you write -2, like the minus first and then the 2, so -2, that's okay. But the real chemistry way of doing it is to write 2 minus. That's how chemists write their charges. They put the number first and then they put the charge. But I won't care if you write -2 or 2 minus, either one will do. Yes. You would say 1 plus, yeah, or 2 plus. So actually, to be honest with you, when you have a single positive charge, we usually leave off the number altogether. So instead of writing +1, we would usually just write plus. Instead of writing 1 minus, we would usually just write minus, okay? But I'm not going to get mad at you or take off any marks or anything. If you were to write this as 1 plus or +1 or plus, all 3 of those are okay. It's just this one is like the one that we use the most. That's the one that chemists use, okay? If you write -1 or -1 minus or -1, that's okay, but this is the one that chemists will use, okay? And if we had +2, you could write it like that, but this is how a chemist would write it. So try to use this one, but if you forget and use that, it's no big deal, okay?
I can write the symbol for this ion as O2 minus to show that it has a 2 minus charge, whereas this neutral guy over here, I can just write O. This is an ion because it has a charge, and there's a specific name for it. We can call this an anion, which is the word that we use to describe a negatively charged ion that has more electrons.
A-N. I'll write it up here. It's a little bit hard to see there. A-N-I-O-N. So a cation is positive and anion is negative. There's a couple of ways to remember that one. You remember the cats have paws, so cations are positive, or there's that T in the middle, so that's a positive ion. This is the way I learned it when I was in high school. Anion kind of looks like the word onion, and what do onions make you do? Cry. They make you cry, and crying is kind of a negative thing, yeah, especially if it's from onions, because that's unpleasant. It's not like happy tears or anything like that. Another way to do this is to say I have a negative ion. A negative ion is an anion, okay? Either way, whichever way you like those are ways to remember that an anion is negative.
Electrons and protons. Okay, here's just a little bit of vocabulary for review. So an ion is an atom or a group of atoms that have a charge.
We're not going to worry too much right now about the group of atoms, but it will come in handy in Unit 4, which we're going to do next. after this one. Unit 4 is about naming and formulas of chemical compounds. So right now we're focusing in on single elements, single atoms. In the next unit, we're going to be combining those atoms together to make compounds like carbon dioxide and water and sodium chloride and all of those combinations.
Okay, now it's possible for an atom to be neutral, which means it has no charge, means it's not an ion. But if something is an ion, it can be either a cation, which is what we call a positive ion, or it can be an anion, which is a negative ion. Here's a way that I use to remember this, okay? Anion, I think of this as standing for a negative ion, okay? And then cation, you can remember this, it's really cheesy, but you can remember this because cats have pos, and a cation is positive. All right? You'll never forget it. I swear, you'll never forget it. Okay, there's one more thing that I want to mention. I've said that an ion is an atom or a group of atoms with a charge. I haven't said anything yet about the group of atoms. So more than one atom can come together, they can stick together and form a group or a clump, and then that whole clump of atoms has a charge.
Now, I want you to think about math, and I don't know if you guys do this anymore, but if you have a many-sided figure, like this one, or this one, or any of those many-sided figures, do you guys know what we call those? Polygons. Polygons have how many sides? Many. So what does the prefix poly mean? Poly means many. So if you have a group of atoms, how many atoms do you have? Many. So we could call those ions polyatomic because they have many atoms, polyatomic ions. And we'll talk a bit more about that later.
When this happens, we call it a polyatomic ion, a group of atoms that have a charge. Poly means many, and atomic, so you have many atoms together that form an ion. I'll talk about polyatomic ions in future videos, so you want to check those out if you need to learn more about polyatomics. Anyway, just to review what we've learned. We learned that an ion is an atom or a group of atoms that have a charge, and something gets a charge when the number of protons and electrons don't balance out. You have more protons than electrons, you'll have an ion with a positive charge, you call it a cation. You have more electrons than protons, you have an ion with a negative charge, and you call that an anion.
Okay. So let's go through that and make sure we didn't miss anything. All right. So if you missed anything, don't worry. We had our sodium atom. Whoops. And what did it do when it became an ion? Did it gain an electron or lose an electron? It lost an electron. So we lose one electron. And it was actually this one here. This one was like, bye-bye. Okay, and you can see that it is now missing. There. And if we had 11 protons and 11 electrons, what is the net overall charge? 0. And so that would mean that it is neutral, which means it has no charge. And to write the symbol for a neutral atom, you just write the atom. Na, no charge. You don't have to write the 0. Okay, we don't write zeros up at the top if the charge is 0. After it lost an electron, the number of electrons is now 10, and the number of protons is now 11. What is the net or overall charge? +1, okay? And I'm going to say 1 plus, okay? Or +1. And the symbol is just, whoa, that went crazy. Symbol is just Na. And what's our favored way of writing a positive 1? Just a top right corner, and we just write a plus. Okay? Or 1 plus, or plus 1. Okay, whatever floats your boat, whatever you like. And instead of being an atom, that's now no longer a sodium atom. This is now an ion. Atom has no charge, ion has a charge. Brooklyn, you look puzzled. You're good? Oh, okay. Yeah, no, we're not on oxygen yet. This is still sodium. Okay. So here we have now oxygen, and this is on the left-hand side, we have an oxygen atom, and it becomes an oxygen ion. And in order to do that, you'll notice that we've got like a little blank space up here, and we got a little blank space down here, and all of a sudden, in comes an electron. Here it comes, is going to go in there, and another electron is going to come in, and it's going to go in there. So what's happening? That oxygen is gaining or losing electrons? Those electrons, they're going to go in and fill in there. They're going to go in and fill in there. So it gains 2 electrons. Okay, and you can see those 2 electrons that it gained are there and there. So we started with 8 and 8. So we had 8 positives and we had 8 negatives. Now we still have 8 positives because we never change the number of protons. But now we have 10 negatives. What is the overall charge of the ion? 2 negative. Or -2 if you prefer. Okay? What was the oh yes, sorry. The protons never change because if I was to change the protons, like let's say I changed it to 7, I would no longer have oxygen. I would then have nitrogen because nitrogen has 7 protons. Yeah? So the protons never change. Yep. Good question. What is the overall charge of an oxygen atom? From my right-hand side of my room, and not Celine. What is the overall charge of an oxygen atom? It is what, sorry? Neutral, very good. 0, neutral. Okay, so the symbol for oxygen atom, which is neutral, is just O. But the symbol for the oxygen ion, which is O, and it's going to be 2 negative or O -2 if you prefer. What's the name we give to a negative ion? Anion. And I think I forgot that on the previous page. So if you missed it, on the previous page, you might want, or no, it's on the same page. It's already there. Cation's already there. Never mind. What is the definition of an ion? An ion is an atom. Whoa, what happened? Sorry. An atom or a group of atoms with a charge. What does it mean to be neutral? No charge. What does it mean to be a cation? Positively charged ion. And if it was a positively charged ion, did it gain electrons or lose electrons? It lost electrons. An anion is... You guys need to be faster on the uptake because they're like kicking your butt over here. It by the way, it did, yes. Ion, and it gained electrons. Now, you do not need to know the word mnemonic device. However, apparently one of my former students really impressed their psychology teacher because they were like, I know what a mnemonic device is. And they were like, where did you learn that? And they're like, in science class. And then their psychology teacher was really excited because a mnemonic device is a memory aid. So I guess it's a term they use in psychology, is like something to help you with your memory. Because the word mneme is from the Greek for memory. It helps you. What is a mnemonic device? Tell your partner, to help you remember that anions are negatively charged. Okay, so your first mnemonic device. Anion sounds like, or looks like, onion. And onions make you cry, and that is negative. What's the other way you can remember? And who has a mnemonic device to help you remember that cations are negative? Please raise your hand if you have one. I want someone over on this side of the room who is not Celine. I know, it's frustrating. I'm sorry. I was always that person too. I was like, let's move it along, people. You can go to the washroom. Lucas, how can you remember that the name of that a cation is positive? What do cats have? They have paws. There's actually another one. I don't know. In your book, do you have room for two of them or just one? Does it say two? Does yours say 2 or 1? It's okay, don't worry about it. We're gonna give a second one. In the second one, we've got the T looks like a positive sign. What does poly mean? Poly means many. So a polyatomic ion is a group of atoms. In other words, many atoms. So that takes care of the polyatomic part. What takes care of the ion part? It's a group of atoms with a charge. Okay? All right. Are we good with that? We done? Excellent. Let's go to ion formation. And this is going to be a little bit of review of Bohr models, which we did before the break, so you've probably forgotten at least some of it. So we are now on page 95. I want you guys to look at this pen. Everybody look at this pen. Where is it more stable? Here or there? There. Less stable? More stable. Okay? Does nature want this pen to be less stable or more stable? More stable. So nature always goes to the more stable state. The only way to make it less stable is for me to actually do some work and pick the darn thing up. Yes? Okay, so nature favors the most stable state. So it always goes from less stable to more stable. We can use another word for stable, or another group of words. When something is stable, it has a low potential energy. Have you guys heard the word potential energy before? Anybody heard the word potential energy? Yeah? Okay, a couple of you. Basically, potential energy means that it has the ability, it has stored energy in it that can cause it to move or that can cause it to do work on something else. And if this thing has potential energy, so if I let go of it, it can move. Once it's here though, it still has some potential energy because I could make it move again by making it go to the floor, yes? But every time it gets lower and lower, it has less and less potential energy until you got to, say, the center of the Earth, at which point it would have 0 potential energy. Yes? Okay. So potential, because by the time it got to the center of the Earth, there would be nowhere for it to fall. Yes? Okay. So nature likes to be here. Nature likes to have low potential energy. And because potential energy is such a big, long word, we can just call it PE for potential energy. So what does nature think of this stack of bricks? Over on the left. Does it say, yes, I would like to stay there, or does it say, no, I would like to fall over? I would like to fall over. Yeah, so given a chance, that's going to fall over. How about this one? That's pretty stable. That is at a low potential energy. How about that ball on the hill? Which one is stable? That one is stable. It's not going anywhere, right? It's just going to stay there. This one, it probably is going to roll down. If you get the slightest tap, it's going to roll down the hill. In order to get this one to go up the hill, you would have to push it. It would not go there naturally, okay, just by itself. All right. Now, let's recall, an ion is an atom or a group of atoms with a net, which means an overall what? Charge. In a neutral atom, the number of protons and electrons are the same or equal. In an ion, the number of protons and electrons are they still the same? In an ion, they're different. Or if you wanted to, you could say equal and unequal. You don't have to write both, but protons have what charge? Protons have a positive. Protons have a positive charge. Electrons have a negative. Very good. If the number of protons and electrons are not equal, then the atom will either have an overall positive or negative charge. We call this an ion. Okay, excellent. Next page. Why do atoms form ions? And this is why we were talking about stable and not stable. It turns out that a filled outer shell, do you remember the shells? Whose model of the atom had shells? The Bohr model. And how many electrons was the first shell full with? How many electrons fill the first shell? First shell filled with 2 electrons. How about our second shell? Second shell is full with 8. It's a good thing we're reviewing this. It's been a long time, hey? And then the third shell is full with 8 electrons. So let's fill in those electrons in order. Where do we put the first electron? First electron goes at the top. And the second electron, does it go? I've got 2 choices for you. Is it the red electron or is it the blue electron? Which one should it be? Blue. Okay. I don't know if you guys remember, but electrons have little rooms they can be in. Do you remember that? The first shell has 1 room. Yeah? You don't need to draw the box. It just lets you know that that's the only place electrons can live because there's only 1 room. Second shell. What is wrong with my pen? Let's get a different pen so it works. Oh, yeah. Oh, yeah. Oh, yeah. There we go. Second shell. Oh, you guys get a brain break while I find a pen that works. So if you would like to stretch, if you would like to, you know, not everybody can go watch it at the same time though, all right? That's fun.
Sorry, I was just wondering.
Yeah.
Is tomorrow early enough?
Yeah.
Okay, thank you so much.
Mhm.
Sonia and Audrey go on a tiny brain break.
Tiny brain break.
Tiny
Yes.
brain.
Yes. Oh, there's the other pen. We're waiting for my pen to like come back, so I've closed it and opened it because sometimes when you close a program and open it, sometimes things work again. Well, we're going to learn something new, but we've got people on a brain break now, so we're just taking a little mini brain break, and then we're going to finish the lesson, and then we may or may not have homework today. Okay? Depends on how far we get. Yeah? Okay. Uh-huh. Yes. That's awesome. And you have turned, let me guess, hang on. 13, 14, which, no, it's grade 9. You're in grade 9. You're in grade 9, 14. 15. Oh, that's right, because we're in the new year. We're in the new part of the year. Oh, yes. Congratulations. That's awesome. Okay, I've got a working pen again. Look at that. So exciting. So we have filled in the first 2 electrons. On our second shell, where are the 4 rooms? There's a room at the top. There's a room on either side. And there's a room at the bottom. So if we want to put in the 8 electrons on this shell, we're going to put in 1 at the top. Where does the next one go? On the side. 1, 2. Third one goes on the bottom. 4, and then 5, 6, 7, 8. And then the third shell would do the same pattern again. Okay? Now it turns out, Lucas and Zelyn, it turns out that a filled outer shell is very stable. What does that mean? That means nature wants the outer shell to be full. Okay? So what's going to happen is that atoms will tend to gain or lose electrons until They've either filled their outer shell or emptied it. Okay? So they're going to gain or lose electrons to either fill or empty their shell. The outer shell is called the valence shell. That's our outer shell. That's a new word, new vocab word. Okay? Now, one of the things we're going to do is we are going to decide, is our outer shell closer to full or is our outer shell closer to empty? If it's closer to full, we're going to fill it up. If it's closer to empty, we're going to empty it out. Yes? So if we have an atom, and remember full for shell number 2 and shell number 3, how many is full? 8 is full. What's halfway full? 4. So what's more than halfway full? 5 or 6 or 7. So we are closer to full. What is wrong with you all? Do you not want to learn? Because if you don't want to learn, just put your head down on the desk and stop making noise and distracting others. Okay? So halfway full is 4. 5 is more than halfway. 6 is more than halfway. 7 is more than halfway. So if you are more than halfway, are we going to fill the shell or empty the shell? We're going to fill it. So 5, how many would we need to add to fill it? 8 is full. 3. So if you have 5 electrons, you are going to gain 3. If you had 6 electrons, how many would you need to gain to fill it? 2. If you have 7 electrons, how many would you need to gain to fill it? 1. Okay, so anytime you have 5 or 6 or 7 electrons, you are going to gain electrons to fill it up. That's what happens to form anions. Atoms that have 5 or more valence electrons. What the heck is a valence electron? That's an outer electron. That's an electron on the outer shell. So we've got 5 or more valence electrons. That's our outer shell. So a close to full valence shell, those will gain electrons. And it turns out, and this is going to be something that, again, you've probably forgotten, but that's okay. Atoms with 5 or more valence electrons are all non-metals. Ooh, that was again before spring break, non-metals. Take a look at that periodic table up on the wall, that far wall there. We've got some blue elements, we've got some purple elements, and we have some pink elements. So look at this one over here because it's got all the colors. That wall there. It does, but they're not as obvious. Okay, I want you to look at the blue and the purple and the pink over there. Okay, blue, purple, pink. Do you remember whether blue or purple or pink is non-metals? Blue is metals, pink is non-metals. And then purple are called metalloids. We're not going to worry about those too much. So the non-metals, those are the ones that are gaining electrons. And let's look at what happens here. Fluorine doesn't stay fluorine. When it becomes an ion, it becomes fluoride. Yes. Not the fluorine. And it's a good thing because fluorine would literally eat right through your teeth. Fluoride is good for your teeth. Okay? And it becomes helpful rather than harmful. Yes. 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 Oh, I've put the empty space on the right because that's the way the diagram came when I stole it off the internet somewhere. You could put it on the left side, yes. Yeah. To be honest with you, the whole top, right, bottom, left is the way I've done it to make it easy for you to remember. As long as you don't pair them up until they have to pair, it really doesn't matter where the empty spaces go. But by doing it that way all the time, it means you will never pair them up unless you have to. Yeah? Good question. So fluorine has 7 valence electrons. Whoops. So it has 7 electrons on the outer shell. 1, 2, 3, 4, 5, 6, 7. Okay? 7 valence electrons. That's 7 electrons on the outer shell. How many electrons does nature want it to have on the outer shell? How many electrons does nature want fluorine to have on its outer shell? It wants it to have 8. So what does it have to do? If it loses one, it's going to have 6. Does it want to have 6? No, it wants to have 8. So it needs to, valence electrons. It has 9 electrons, but 2 of them are in the inner shell, and we don't worry about those ones. Okay? Because the inner shell is full, we just want to leave it alone, because full is good. Okay? So here comes an electron, and it's going to go into that empty space. So as we go from here to here, we gain 1 electron. Where is that electron? It's right, well, I guess it went on that side. Okay, there's that electron that we gained. So now we have 8 electrons. We still have 9 protons. So we went from a fluorine atom that has a 0 net charge to a we don't call it fluorine anymore, we call it fluoride. And it has 9 protons, but now it has 1 extra electron. And so what is its charge? It is -1. Okay. And now you guys are going to try the next one. What I've got here is I've got a sulfur atom. It's been drawn for you. Sulfur is atomic number 16, so it has 16 protons. There are 16 electrons here. So you guys are going to write down how many protons it has. It's right there, literally, yes. So you're going to say it has how many protons? 16. How many electrons does it have? 16 electrons. What's its net charge? 0. What is the symbol for sulfur? Just S. And if we wanted to, we could add on that this is S. Where does its atomic number go? Bottom, left, so 16. What goes up at the top? Mass. What is the mass of this atom? We have 16 protons. We have 16 neutrons. So its mass is 32. But it has no charge, so nothing goes at the top right. How is sulfur going to become lower potential energy? How is sulfur going to become stable? Yeah, we've got an empty hole right here, and we have an empty hole right here, yeah? So we're going to fill that up with another 2 electrons. So now we still have 16 protons, but how many electrons do we have now? We have 18. We have 2 extra electrons. And so the net charge is -2 or 2 negative. And so our symbol would be sulfur with a 32 and a 16. And where does the -2 go? Top right. And I'm going to put 2 negative, but if you put -2, that's okay. What does the name become? It's not sulfur anymore. Sulfide. IDE. So anions names end in "ide." Negative ions, anions, end in "ide." Positive ions don't do that. It's just the negative ones. Okay? I want you guys to try this one on your own. Try this one on your own. No homework today.